Ah. Hello everyone, we are excited to present our college project titled Home Automation System using Synric Pro and Node MCU. This project aims to make controlling homes household appliances smarter and more convenient by integrating Google Assistant with IoT components like Node MCU and a 4 relay module. The main goal of this system is to showcase how we can automate devices such as lights, fans, or any other electrical appliances. It provides convenience, saves energy, and adds a modern touch to traditional homes. With just your voice, you can control devices from anywhere using Google Assistant. Our team has worked together to design, code, and implement this system, ensuring it works seamlessly. In this presentation, we'll explain how this system functions, the technologies involved, and demonstrate its real-world application. Let's begin by understanding the components and technologies that power our project.
To build this project, we have used a combination of hardware and software. Let me walk you through the key components. First, we have the Node MCU. This microcontroller has built-in Wi-Fi, allowing it to connect to the internet and communicate with other devices. It acts as the brain of a system. Connected to the Node MCU is a 4-relay module. This hardware controls appliances by turning them on or off. Each relay corresponds to one device such as a fan, light, or any other electrical device. For the software, we use Synric Pro, a cloud-based platform that acts as the bridge between Google Assistant and the Node MCU. It handles all the commands and it communicates them to our system. This makes it easy to integrate voice commands into a project. The programming was done using the Arduino IDE, where we wrote and uploaded the code to the Node MCU. Additionally, Google Assistant acts as the voice interface. By linking Synric Pro to Google Assistant, we can control appliances using simple commands like turn on the light or turn off the fan. Together, these components form the backbone of our project, ensuring seamless communication between hardware, software, and the user. Next, let's dive into how these components work together to automate appliances.
So let me explain how the system works and how all the components are interacting. When a voice command is given to the Google Assistant, such as let's say we say turn on the light, so the command is sent to Synric Pro. Synric Pro acts as a middleman between us and the Node MCU microcontroller. So when we give this once the MCU receives the command, it processes it and activates the corresponding relay on the 4 relay module. So whichever light we have, whichever appliance we have, let's say in this case we have asked to turn on the light, right? So it turns on the corresponding relay of the 4 relay module. Then the relay then switches to connected appliances and it turns it on or off according to the command. Let's say we turn on a fan. Similarly, we can ask the Google Assistant to send a request to Synric Pro and communicate with the Node MCU. Node MCU activates the relay linked to the fan and the fan turns on. This is how it works for other devices as well. On the hardware side, the Node MCU is connected to the 4 relay module through GPIO pins. Each relay controls one appliance. This system also includes manual switches, so you can control appliances without using voice command. This seamless integration of hardware and software ensures that the system is responsive and user-friendly. To make this process clearer, we'll also demonstrate it in action shortly. But first, let's take a look at the code that powers the system.
Now, let's take a look at the code that makes our project work. Okay, so the code is written in Arduino IDE and consists of several key components. Firstly, we configured the Synric Pro platform. We registered our devices on Synric Pro and added their unique IDs, app keys, and secret into their code. This allows the Node MCU to connect to Synric Pro and receive commands. Next, we configured the Wi-Fi credentials so that the Node MCU can connect to our network. We also defined the GPIO pins for each relay. For instance, GPIO 5 is connected to relay 1 and GPIO 4 to relay 2 and so on. Okay, so these pin definitions allow us to control applications programmatically. The logic of the code handles two main functions. First, it listens to commands from Synric Pro, such as turning a device on or off. Secondly, it checks as the state of the manual switches. If a switch is toggled, and the code updates the relay state and sends feedback to Synric Pro, ensuring the system stays in sync. Now, let's take an example from the code where Synric Pro sends a turn on command for device. Okay, so the node MCU activates GPIO 5, which triggers relay 1 to turn on the connected appliance. Similarly, the code handles manual inputs by checking the state of the connected switches. By combining these elements, the code ensures that smooth operation of both voice command and manual control is done. Now, let's take a look at the system in action with a physical demo.
Here we have a complete setup of our home automation system. Let me walk you through it. On the table, we have a Node MCU microcontroller connected with 4 relay modules. Each relay is wired to an appliance. For demonstration, we have connected 2 small bulbs and a monitor. Now let's see the system in action. I will give the command to the Google Assistant and you can see it working. Turn on my monitor. Turn off my monitor. Turn on kitchen light. Turn off light. Turn on night lamp. This system is reliable, responsive, and user-friendly, making it a practical solution for smart home automation. So this was our whole demonstration of our project. Thank you.